Hello and welcome to everyone in physicsfire. Today we are going to do the third chapter of class 12. That is current electricity. We have done the first chapter as well as the second chapter. If you'll see the first chapter, that is electric field and charges, that comes under electrostatics. The second part is electrostatic potential and capacitance, and the third chapter is what? Current electricity. If you'll see electrostatics, right? So here the velocity of the charge is 0. That is what we learned. The whole first two chapters is what? Electrostatics, where the velocity of the charge is what? 0. Right? Let's see the next we are going to do is current electricity. See, where the velocity of the charge is constant. Is what? Constant. Yes. The third chapter is what? Magnetism. So there we will see that the velocity of the charge will be what? Variable. Fine. So let's come to current electricity, today's topic. Of course, it is a big chapter. Too many concepts are there. But anyway, it is an interesting and not that difficult chapter. Let's see current. Current, if you will see the flow of charges per unit time. We already learned what is charge in the first chapter. If you haven't seen, then you can watch. It is there in the playlist. So flow of charges per unit time is what? Current. Flow of charge per unit time. So we can say I is equal to Q by T. Generally, we say average current or instantaneous current. So let's write average current. That is what? Delta Q by delta T. Delta Q by what? Delta T. Right? So delta Q by delta T means what? Q final minus of what? Q initial divided by T final minus of T initial, right? Second thing is what? Instantaneous current. Instantaneous. Yes, current. So there it is going to be what? dq by dt. We know that what? Instantaneous, suppose current is flowing from A to B, right? So at each and every point from A to B, if you will see, that we say what? Average current. But particularly if you're finding for this area, then we say what? We say it is instantaneous current. Understood? Now let's see. So we understood what is instantaneous current, what is average current. Now before starting any numerical, let's start like what is the unit of current, which type of quantity it is, right? So if you'll see, unit of current is ampere. Unit is what? Ampere. Denoted by what? A. Or charge per unit time, so charge by second, right? Coulomb per second, that also we can say. Fine. If you find the dimensional formula, then for charge is what? I, what is that? Q is equal to I into T, right? So ampere into time by what? Time. So ultimately it comes as what? A. By that way also you can find. Fine. And one more thing, current is a fundamental quantity. It is a fundamental quantity. That's why it does not depend upon anything. Fundamental quantity. 7 fundamental quantities are there. Out of that, current is also there, right? Like what? Distance, mass, time, right? Electric current, temperature, amount of substance. These things are there as what? Fundamental quantities. Let's see what is the physical, whether it is a scalar quantity or vector quantity. If you'll see, we can say, suppose current is flowing like this. This is 2 ampere and this is 3 ampere at an angle of 90 degrees. So ultimately we are going to get So 2 ampere, 3 ampere, that comes as what? 5 ampere, right? So of course we'll think that it is having direction 2 ampere and 3 ampere. It is coming like this and then it is going like this, right? So we can say, yeah, it is having direction as well as magnitude 5 ampere. So it should be a vector quantity. No. The problem with the vector quantity to be the necessary condition is what? It should follow the vector law of addition. That is what? A square plus b square plus 2ab cos theta root under of that. So this angle there, it is not considering. Directly we are adding 2 plus 3 is 5. That's why it is not a vector quantity. So we are saying it is a scalar quantity. Actually, it is not even a scalar. It is what? Tensor quantity. But we don't know now about tensor. So we are saying it is a scalar quantity. Hope so you guys got it. What is current? What is the unit of current? And then what is average current and what is instantaneous current? Okay. So let's see 1-2 questions on average current and instantaneous current. Suppose if you wrote like before that, let's see one more thing. As we learned, instantaneous current is dq by dt, right? So we can say I into dt is equal to what? Dq. So if you want to find I, then you have to differentiate. If you want to find charge, then you'll have to do what? Integrate. From that, we can say one more point, that what we can say, that if you want to find, if you'll say area under IT graph, I versus T graph will give current, charge. That is what we are doing. Area integration is ultimately finding area, right? The small part to add it. Hope so you guys got it. So I is equal to dq by dt. From that we can say I dt is equal to what? Dq. One more thing, we can say that I is equal to q by t. So q is equal to what? Ne. So from this formula, we can find number of charges. What we can find here? Number of charges, right? Suppose I into T by E is equal to what? Number of charges. Fine. Suppose electron is revolving. If electron is what? Revolving. In case electron is what? Revolving with a velocity v in radius what? R. So we can find there also current, right? Because it is revolving, flow of charge per unit time. So for that we'll have to first find what? Time. So time is going to be, let's consider a circle, right? Radius is what here? R. An electron is revolving, right? So we can say time period is what? 2 pi R by V. We got time period, right? I is equal to Q by T. But they are saying that what? Suppose directly you are supposed to find current. You are supposed to find what? Current. I'm writing it. Current at any point. Current at any point of orbit. Of what? Orbit. So that is going to be what? I is equal to, we can say that what? Charge flown in 1 second, charge flown in 1 second into what? The frequency. Into what? The frequency. So charge is what here? Electron, right? Frequency, what we can write here? Frequency, what we can write? Frequency just opposite of what? Time period. So V by 2 pi R. Yes, this is going to be the current when it is revolving, when the electron is revolving. We have one numerical on this, that also we are going to solve. Let's see now 2 questions. How many electrons pass through a lamp in 1 minute if current is what? If current is in 1 minute, and then what? Current is 300 milliampere. So both you'll have to convert into what? First, time is in second, and the current you'll have to convert into what? Ampere. So we know I is equal to how many electrons they are saying. So I is equal to Q by T. Q is equal to what? Ne by T, right? Okay, I is how much here? 300 milliampere. So you will have to convert that milliampere into what? 10 to the power minus 3 into N into 1.6, electron value 1.6 into 10 to the power of minus 19 divided by what? Time. Time is what? 60 seconds. So all those things will go here, right? 3. So it is going to be 0.3 into what? 60 divided by what? 1.6 into 10 to the power of minus 19 is equal to N. So it will be 18. 18 divided by 1.6 into 10 to the power minus 19. The answer comes as what? 1.125 into 10 to the power of 20 electrons. That will be the number of electrons. Calculate, you'll get answer. Fine. The next question, what it says. So what I did, I is equal to Q by T, nothing else. Next question, it says about what? In a hydrogen atom, same, the formula we learned too. In a hydrogen atom, an electron moves in an orbit of radius 5 into 10 to the power minus 11 meter with a speed of this, right? With a speed of 2 into 10 to the power minus of this, like plus of this. Find the equivalent current. Fine. Directly we can say we have the formula now. What is that? I is equal to, see here, I is equal to V by 2 pi R. I is equal to E into E is what? E into V by 2 pi R. So we can say now E is what? 1.6 into 10 to the power of minus 19. Velocity is how much here? 2.2 into 10 to the power what? 6. Radius 2 pi R. 2 into what? 3.14 into what? Radius. Radius is how much here now? Radius is 5 into 10 to the power of minus 11. If you solve it all, you will get what? Here current. That current you are going to get how much? 1. So the current you are going to get this. If you'll calculate all this, you'll get this answer. Hope so you guys got it. Now we understood I is equal to Q by T and I is equal to E into V by 2 pi R. Many times in NEET they ask these types of questions. Let's see now. We learned average current and then what? Instantaneous current. So we let's try a question. Third question is what here? Let's consider charge is given 4t square plus 3t plus 2. Find current from 2 seconds 0 to 2 seconds. Right, that's the first question, part A. Find current. Again, you will have to find current. Find current at 4 seconds. At what? 4 seconds. Let's see now solution. So as I told before itself, that find current from means average you will have to find. So I average is what? I average is delta Q by delta T. Delta T is what here? Q final minus of Q initial, right? Q final minus of Q initial by what? T final minus of T initial. Q final is how much here? Now you have to put the time value. Q final 2 seconds. So 4 into 2, 4 into what? 2 square, right? Plus what? 3 into 2, correct? Plus what? 2, plus 2. That we got minus of what? You put 0 everywhere. 0, right? If you put 0 here, 0 here, also 0 here, 2. So minus of 2 divided by 2 minus of 0. So that is going to be how much? 16 plus what? 6 plus 2, 8, 8 plus 24, 24 minus of 2 divided by 2. So that is going to be how much? 22, 11, 11 ampere. That is the answer for current. Now the same question they are asking, that what? Find current at 4 seconds. So it's easy. I is equal to what? Second part, B part is I is equal to, we can say dq by dt. I is equal to what? Dq by dt. Now differentiate it. If you differentiate, then it becomes what? 8t plus what? 3 plus 0, right? The constant differentiation is 0. Now put time here 4, then it is 32 plus 3, right? 32, 8 4 is 32. You will put here time value. So that becomes as what? 35 ampere. So by that way, you can find average current and instantaneous current. In case if they give like what is like, they'll give you the value of current and then they will find charge. Let's see the question number 4. Suppose if they gave the value as I, question number 4. Just a minute. Question number 4 is what? I as given 2t square plus 4t plus 3, right? Find current, find charge, not current. Now current is already given. Find charge from 0 to 2 seconds. Obviously we are finding area, so there should be a range from where to where, right? So let's see the solution. Now here we know I is equal to what? Dq by dt, right? We want to find q, so we can say I dt integration is equal to what? Dq. Dt integration here is what? 2t square plus 4t plus 3, right, into dt from where to where? 0 to 2 second is equal to dq integration is q only. Fine. Now integrate it. If you integrate 2t square, that is going to be 2 into t to the power 3 by 3, right, plus what? 4 2 to the power n, right? And 2 to the power n. So we can say 2 x to the power n. N is x to the power n is what? N plus 1 divided by n plus 1. So 4, oh no, 4 not 4, t square divided by 2. After that what? 3t. Yeah. Now that is equal to what? Q. So everywhere you'll have to place what? 0 to 2. So put here 2, 0 to 2. Then it is going to be how much now? 8 by 3 plus what? Now you put here again 4, 2 to the power t to the power 2. So 4 by 2, and that becomes 6 is equal to what? Q. So this gets cancelled out. This gets 2. So it becomes what? 8 plus 8, 16, 16 plus 8. So 24. Charge is equal to what? 24 coulomb. Sometimes they ask find the number of electrons. Again, Q is equal to divide by what? Electron. Like electron means what? 1.6 into 10 to the power minus 19 coulomb. These are the basic questions from this chapter, from this topic, which they can ask. Now let's see how current flows, where it flows. Obviously, we know that what? Always current flows in a conductor. Fine. How it flows? See, suppose any conductor is there, electrons are free in a conductor. Suppose any conductor, let's consider this is also a conductor, the nib of this, right? But I'm touching this, there is no current, right? Let's see why there is no current. That we are going to discuss now. So let's take an isolated conductor. Let's take an isolated conductor and we gave an external E external field. Obviously, n number of free electrons will be there. The electrons will be in a zigzag motion, right? So what will happen once you'll apply an external electric field in this isolated conductor? Isolated conductor. So what will happen? One side the positive charges will go, one side the negative charges will go. Let's consider, we are considering that electrons are in this direction, not considering electrons will come this direction, positive protons will come in one direction. So here what will happen? Induced electric field. We learned in electrostatics that what net electric field inside the conductor is 0 because E induced is equal to what? E external. Why this happens is once the charges will come negative this side, positive this side, that will be at stationary. Still the charge is moving, but most of the majority of the charges are what? Stationary. So it is not moving. External, the current will become what? A net electric field is what? 0. So we can say E external is equal to minus of what? E induced magnitude wise, if you will see. So net electric field is what? 0. No movement of the electrons. Fine. Now we want what? We want the story of current. This charges which is accumulating at the end, that should flow. So to flow those charges, what we'll have to do? Let's see now. Yes. Okay. Now this all you connect with a battery. Again, you give an external field. If you'll give an external field, so what we are going to do here ultimately, this side negative charge, this side is what? Positive charge, right? That is what is going to happen. But now it will not be at rest, these charges, because this side is positive, all these charges will flow. Now it is a connecting rod, like connecting wire is there. So what will happen? All the charges will flow from one side to another side. So suppose this electron is there, will experience a force, right? Of course, it will come in this direction, right? It will have some acceleration. So that electric force, right, will be there. So of course, now the charges will not be at rest. It is continuously in motion, right? So it is experiencing a force also. So that force, electrostatic force, is equal to, we can say, Q into E. So that is going to be what? Minus, because electron is there, and negative charge. And then F is equal to, we know, MA also. So we can say both, if you equal, then A we are going to get as what? E minus of EE by M. So that we got A. Okay, fine. So without the conductor, without the battery, what happens here exactly? If you will see that electron is there, it is going here. Of course, there will be the room temperature. Room temperature is sufficient to move. In 1 meter cube of a conductor, if you take 10 to the power 28 electrons, the n number of electrons, crores of electrons are there. So those all crores of electrons is always in what? Random motion, right? Due to thermal energy, right? Thermal agitation will be there. Due to those thermal energy, the electrons will all continuously will move. Like it will go here, it will go here, it will go here, ultimately come here. So the net velocity here is going to be what? 0. The velocity is going to be what? Here, 0. The average velocity of these electrons is going to be what? 0. So we can say, if you'll write U average, that is U1 plus what? U2 plus what? U3 till what? UN, right? By N, that is going to be what? 0. Without a battery, right? Once you connect the battery, then what is going to happen? Electrons are moving from here to here, then from here to here, then from here to here, ultimately it comes here. But now see, in between many collisions happen. Suppose the electrons are going from this place to here. In between, many positive charges will be there, right? Of course, it is leaving the proton, leaving, suppose it is a iron metal, so electrons came out from that. Electrons are not there, but it becomes a positive ion, right? Positive iron ions. So those ions, from those ions, electrons will hit continuously. Now when the electrons are moving without the battery, only due to thermal energy, the velocity is 10 to the power 5 meter per second. It's too much. 10 to the power 5 meter per second. When we connect the battery, When we connect the battery, still there is a thermal energy, right? So the velocity is going to be the same. Now what we are thinking that yes, acceleration will increase too much, but that is not the reality. Now the problem here happens is what? N number of collisions will be there. Those positive iron ions will be there, right? Electron will come, directly it will hit here, right? So what will happen? 0. Again it will go here, again it will go. So what is happening? Ultimately electrons are drifting from one place to another place. Like if continuous collisions are there, collision does not mean that the velocity is change or some velocity change, right? Speed changes, the velocity is getting affected here, right? Before the velocity is 10 to the power minus 10 to the power 5 meter per second. Now the velocity is not going to be 10 to the power 5 meter per second. That velocity is going to change. That velocity is going to what? Change. Let's see how much it's changed. The velocity becomes as, that velocity is known as drift velocity actually. That becomes as 10 to the power of 4 minus 4 meter per second. From 10 to the power plus 5 to it becomes what? 10 to the power minus 4 meter per second. See, simultaneously due to thermal agitation, the randomness will be there continuously. Due to that 10 to the power 5 meter per second will be there. But when the electron is drifting due to the external like electric field from one place to another place like this, right? So that velocity is going to be what? 10 to the power minus 4 meter per second. Okay, fine. Next is what? When we connect the battery here, there is a displacement. Now the velocity, because electrons are drifting, the drift velocity is what? Not equal to 0. Before the velocity was what? 0. Now it is not 0. If it is not 0, so we'll have to find, let's see how we'll find this drift velocity. Drift velocity formula, if you will see, Vd is equal to minus of EE tau by m. We are not taking the minus. This is the formula what we are supposed to derive. Let's consider, suppose one electron is there, right? One electron is there, it is going from here to here, right? It comes here. Another second electron is there, it is coming from here to here. Another electron is there, from here to here it is coming, like in random direction. I'm just taking for that so that it will be easy. So it covers some path, right? Let's take that path is lambda, mean free path. What is that? Lambda, mean free, or we can say free path. Lambda 1. It will take some time to go from one place to another place with initial velocity u1, with initial velocity u2, with initial velocity u3. So that time is tau 1. Again here is what? Lambda 2 t2, lambda 3 t3. It is lambda 2, not t1, right? So now we found that what? How much time it will take, how much lambda it will take, and then tau is what? Your relaxation time. Relaxation time. So now you understood how electrons flows, how drift velocity came into the picture. Fine. So if somebody will say like define drift velocity, the average velocity of all the electrons is known as what? Drift velocity. Simple. Let's see, we'll define it later also. So now we are going to derive the formula of what? Drift velocity. If you'll see for all the average velocity, if you want to find, so you will write what? V is equal to u plus at, u1 plus what? A t1, a tau 1 plus what? u2, right? Plus what? A tau t2, right? Then what? u3 till what? un plus what? A tau n, a tau n. Yes or no? Like this it will happen. Okay. Now what we are doing? We are doing here u1 plus u2 plus u3 till what? un by u. That we already did, right? And then we are taking here common as what? Tau. Acceleration, because acceleration is same. So tau 1 plus what? Tau 2 plus what? Tau 3 till what? Tau n divided by what? N average we are finding, no? So V average. Fine. Average, we wrote age here. I wrote age here. So average, right? Fine. So this we know directly 0 because it is without the conductor, that becomes 0. Fine. Now here is what? Tau, if you will see, x tau by n. For one particle, if you see a tau, right, that is actually drift velocity Vd. So now a we already found. A drift velocity is equal to a is what? E tau by m. Very good. So we got the formula what we were looking for. So drift velocity is equal to what? E tau by m. Drift velocity is equal to what? E tau by m. Hope so you guys got it, how we found drift velocity. So drift velocity we got as what? The average velocity gained by the electron of a conductor in the opposite direction of externally up, like till the time we didn't apply the external field, right? We didn't got anything. We didn't got drift velocity. So we applied that, we got what? Drift velocity. Fine. Relaxation time. Relaxation time is what? The time taken between two successive collision. Time taken between what? Time taken between two successive collision. Successive collision. Time taken between two successive collision is what? Relaxation time. Fine. There's two definitions in this topic, right? Okay. Till here you guys revise. We'll see in the next class.